Okay, matrices, equations and inverses. And for this question, first important thing to note is that if we take a matrix, we multiply it by its inverse, we will always get the identity. And also importantly is it doesn't matter what order I do that in. So matrix, inverse, identity, that's an important rule and one we see in a lot of questions. Let's go through the motions here and get our numbers. So A multiplied by its inverse. Oops, already going wrong. And that will give the identity, which is the equivalent, matrix equivalent of the number 1. It doesn't do anything to a matrix when we multiply, so we have this and this. Now we need to remember matrix multiplication. Second important point for this particular question. So matrix multiplication, row onto column will give that answer. Same row onto column, give this answer, and on we go. Actually, this is not going to be a lot of use because we've got that 0 in the last place, which will give me 0, and that will hit the A. So it won't tell me a lot about A, and it will do the same here. 0 will hit the B, and no joy there. So what I'm going to do is I'm going to pick my rows and columns carefully enough so that I always get something about A going on. I think I'm going to use that one onto that one. It will give me that answer. Let me work that through. So minus 3 minus 1, I've got 3, plus 1 minus A will give me the answer 0. It's looking very much like A is 4. Let me choose another appropriate one. If I take that one, for example, onto that column, I'll get that answer. If I work that through, minus 4 minus 2 plus the B is 1, that's good enough. That's going to tell me that B is 7. So I know A is 4, I know B is 7, and I can move on. The important principle of matrices multiplying by the inverse to give the identity. First point. Second one, what have we got? We've got this, and we've got to convert it to a matrix. It's going to look something like this. Very easy to do this as long as you know, as is often the case, what you're actually doing. There's the answer, x, y, z, and the numbers we get. So this will be 1, 2, 0. Reason for that is that if I do that onto that, I get that answer. 1x, 2y, no z gives me 7, and we can see that in that top line. Easy to keep going through this now. So minus 3, 1, minus 1. So row onto column gives me 10, which will give me the second line. And finally, that bottom one, row column gives me minus 12. That'll give me that line, and that's the conversion. Good. Well, what we see here, we see the matrix A, not surprisingly. So we've got A multiplied by my x, y, z, which I'm going to want to know, and that's given me the answer 7, 10, minus 12. Matrix equations dealt with very much like ordinary equations in that we do the same to both sides to make things simpler and to get rid of what we don't want. If we use inverse of A and multiply both sides, what will happen? This will become the identity, which is the equivalent of the number 1. So x, y, z, the identity times x, y, z, 8 to the minus 1, which I know, I'm going to slot that in. So if we multiply both sides of the equation by 8 to the minus 1, we get this, and all we need to do is work this out. And same deal. Row onto column, off we go, and we'll get 3 numbers. So x, y, z. First row, minus 7, minus 20, plus 24, minus 3. You can check that. Second row onto column. 7 add 10 minus 12, 5, and finally third row onto column. So 28 plus 60 minus 84. That gives me 4, I believe. And you can check that for yourself, but there we go. I think what we've got is our answer, which is x is 3, y is 5, and z equals minus 4.